All right, folks, we're going to rock through this whole review. I'm going to do the front fairly quickly because I think it's fairly straightforward, stuff you're pretty good at, and we'll spend a little more time on the back because I think that that's the trickier part. So they are doing simple gram to mole calculations. The hard part is they have to be able to write the chemical formula. So we have potassium, which is K with a 1 plus charge. Sulfate, ATE, means that's the polyatomic ion SO4. That has a 2 minus charge. So when we crisscross this is K2SO4. They've got 4.56 grams of the K2SO4, and they are being asked to go from grams of K2SO4 to moles of K2SO4. Moles always gets a 1. Grams always gets the molar mass. So we're going to do 2 times the mass of potassium, which is 39.098, plus the mass of sulfur, 32.066, plus 4 times the mass of oxygen, 15.999. That gets us a molar mass of 174.258. So grams cancel, leaving us with moles. That's what they asked for. So we're going to do 4.56 divided by 174.258. That gets us 0.0262 moles of K2SO4. Very straightforward. I hope that that's second nature to you guys at this point. Aluminum nitrate, we have aluminum, which is Al with a 3 plus charge. Nitrate, ATE, that means it's a polyatomic ion. NO3, that has a 1 minus charge. So when we crisscross this is AlNO33. So remember, when you go to do the molar mass, you got to distribute this 3. That's 3 nitrogens and 9 oxygens. So we're starting with 0.056 moles of AlNO3, and we're going from moles of AlNO3 to grams of AlNO3. Moles always gets a 1. Grams, we need the molar mass. So mass of aluminum, 26.982, plus, make sure you distribute this, 3 times the mass of nitrogen, which is 14.007, plus 9. 3 times 3 is 9. 9 times the mass of oxygen, 15.999. That gets us 212.994. So we're going to moles cancel out, leaving us with grams. We're going to multiply across. So 0.056 times our molar mass gives us 11.9 grams of AlNO3. Hopefully that's very straightforward for you guys. All right, percent composition by mass. That's where we take the molar mass of the formula and we do each element divided by that. So first we need the formula. We have iron 2 carbonate. So remember, the Roman numeral tells you the charge of the metal. So in this case, this iron is a 2 plus. You got to be careful with that because iron can be either 2 plus or 3 plus. Carbonate, ATE, that means you have a polyatomic ion. That's CO3. That is a 2 minus charge. Normally we crisscross this, but since they're the same, they just cancel each other out. So our formula here would be FeCO3. So we're going to go ahead and calculate the molar mass of that. So Fe is 55.845 plus carbon, which is 12.011, plus 3 times oxygen, which is 15.999. That gets us a molar mass of 115.853. Okay, so now to do the percent composition by mass of each element, we're going to do that one at a time. So for iron, we're going to take the mass of iron. It's 55.845. That's our part. Divide that by the whole, so the molar mass of the whole compound, 115.853, and then multiply by 100. So 55.845 divided by 115.853, decimal, 0.853, and then times 100 Typically, we don't really have sig figs on this one, so we usually just do two digits after the decimal. So 48.20% iron. All right, now we do that for the carbon as well. So we take the mass of the carbon, 12.011, divided by the molar mass of the compound, 115.853, times 100. So 12.011 divided by 115.853 times 100. That gets us 10.37% carbon. And then for the last one, this one's a little tricky because we had 3 oxygens. So we have to account for that in our mass. So we're going to do 3 times the mass of oxygen, which is 15.999, divided by our molar mass of the compound, 115.853 times 100. So 3 times our 15.999 divided by 115.853 times 100, 41.43% oxygen. So there's our iron, there's our carbon, there's our oxygen. Alrighty. These last 2, 4 and 5, I'm going to let you guys do on your own. That should be pretty straightforward. We have strontium sulfide, which would be SRS, and then barium hydroxide, which is BaOH2. You're going to do this exact same process. Mass of the element divided by the mass of the compound times 100. If there's more than one of that element, make sure you multiply it by that number. Okay? On the back, this is the part that you will definitely run into on the AP test. And we did this last year in honors, but it's a tough one. All right, so we have allulose, C6H12O6 is a natural sweetener often used to replace sugar, which is C12H22O11, in food products to reduce the number of total carbohydrates and calories. A certain product is found to contain a sweetener that is 40.09% carbon, 6.75% hydrogen, and 53.16% oxygen, and its molecular mass was experimentally determined to be 180.129 grams per mole. Determine the empirical and molecular formulas, then explain how you know which sweetener was used in this product. All right, so step number 1, we're going to change your percentage to grams for each element in the compound. So we were given 40.09% carbon. We're just going to change that to 40.09 grams of carbon. I'm going to do that for each of them. So I have 6.75 grams of hydrogen and then 53.16 grams of oxygen. Step 2, you're going to take and convert grams to moles using the grid. Okay? So we're going to go from grams of carbon to moles of carbon. So 1 mole for every 12.011 grams of carbon. So we're going to do 40.09 divided by 12.011. That gets us 3.34 moles of carbon. Same thing for the hydrogen. We're going to go from grams of hydrogen to moles of hydrogen. 1 mole of hydrogen for every 1.008 grams of hydrogen. So 6.75 divided by 1.008 gets us 6.70 moles of hydrogen. And same thing from the oxygen. Grams of oxygen to moles of oxygen. Moles gets a 1, grams gets the molar mass, 15.999. So 53.16 divided by 15.999 gets you 3.32 moles of oxygen. Step 3 is to divide by your smallest mole. This should get you a whole number, or relatively close to a whole number. All right, so looking at our 3 values that we've just gotten, our 3.32 is our smallest. So I'm going to divide all 3 of these by that 3.32. Obviously, this one is going to be 1. This one is also going to be 1. It's not perfect, but it's close enough. Remember, this is experimental data, so it's never going to be like spot on perfect. And then if we do 6.7 divided by 3.3, that's going to get us 2. Those came out to nice, pretty whole numbers. So then the last step is use the whole number as your subscript for your empirical formula. So my empirical formula, we do them in alphabetical order. So it's going to go C, H, then O. We had 1 carbon, 2 hydrogens, 1 oxygen. All right, so that's the empirical formula. They also asked for the molecular formula. The molecular formula is a multiple of the empirical formula. So to find the molecular formula, you're going to take the molecular mass that was given in the experiment of 180.129. And you're going to divide that by the mass of the empirical formula. Okay? So we need the molar mass of the empirical formula. So carbon, 12.011, plus 2 times hydrogen, 1.008, plus oxygen, 15.999. That gets me 30.026. Now, when you divide these out, this should be a whole number. So your molecular formula is going to be our molecular mass divided by the molar mass of the empirical formula. Should be a whole number. 180.129 divided by 30.026. That gets us 5.99999. We want that to be a whole number. That's 6. So for the molecular formula, I'm going to take 6 times the empirical formula, CH2O, and that gives me C6H12O6. So that is my molecular formula. So the question is, which sweetener was used in the product? Well, we had C6H12O6, which is the allulose. So allulose is our sweetener. And we know because of the molecular formula. All right, let's do gum. Popular chewing gums are typically flavored with either spearmint oil, which is C6H14O6, or methyl salicylate, C8H8O3, also known as wintergreen, resulting in a minty fresh breath. A certain stick of mystery gum was found to contain a substance that is 40.01% carbon, 7.70% hydrogen, and 52.29% oxygen, with a molecular mass of 182.163 grams per mole. Which oil is this mystery gum flavored with? Determine the empirical and molecular formulas to reach your answer. All right, so we're going to do the exact same set of steps. So step 1 was to change our percentages to grams. So I'm going to do 40.01 grams of carbon, 7.70 grams of hydrogen, and 52.29 grams of oxygen. Step 2 was to go from grams to moles. So grams of carbon to moles of carbon. 1 mole of carbon is 12.011 grams. So 40.01 divided by 12.011 gives us 3.33 moles of carbon. Grams of hydrogen to moles of hydrogen. For every 1 mole of hydrogen, we have 1.008 grams. So 7.70 divided by 1.008 gives me 7.64 moles of hydrogen. And then grams of oxygen to moles of oxygen. For every 1 mole of oxygen, there is 15.999 grams of oxygen. So 52.29 divided by 15.999 gets us 3.27 moles of oxygen. All right, step 3 is to divide by your smallest mole. Hopefully this is a whole number. So our smallest mole is the 3.27. down here, that's obviously 1. 3.33 divided by 3.27, is that close enough to 1? Yes, it is. If it's, as long as it's 1.0 or pretty close thereof, we can call that 1. And then 7.64 divided by 3.27 gets us 2.34. That is distinctly not a whole number. That is unfortunate. So what do we do if we don't get a whole number here? Well, we're going to multiply by something to get us a whole number. So if this is 0.3, I can multiply this by 3, and that'll get me a whole number, right? So if I take, not 2, 3, sorry. If I take my 2.34 times 3, that gets me a nice, pretty whole number of 7. But these are ratios, so if I multiplied this number by 3, I've got to multiply all of these by 3. So that's going to change that to a 3, and that to a 3. So this case, our empirical formula is going to be C3H7O3. So then to get our molecular formula, we're going to take our molecular mass that was given in the problem, 182.163. We're going to divide it by the molar mass of this. So 3 times the mass of carbon plus 7 times the mass of hydrogen plus 3 times the mass of oxygen. That gets us 91.086. 182 divided by 91. Hopefully you all know in your head that that is 2. So we're going to multiply our empirical formula by 2. So C3H7O3 times 2 gets us a molecular formula of C6H14O6. So what is our mystery gum flavored with? This molecular formula matches the spearmint oil. So this is spearmint gum. Okay? So hopefully that helps. If you've got questions, make sure you ask them Friday morning so that you are ready for peer tutoring Friday afternoon. See you then.